Okay, so 3.7 optimization problems. We're minimum and maximum. So that is, we're going to find a first derivative and find the zeros. That's what we're going to do, because that's how we found minimums and maximums as relative min-max. So a manufacturer wants to design an open box having a square base and a surface area of 108 square inches. What dimensions will produce a box with the maximum volume? Okay, first of all, I didn't want to draw the picture. I was like, oh, we need to do it ourselves. But I went ahead and did it. So square base. So if I was drawing this picture, I would draw a square. And then I would make myself a box. Now, it's open. So that means there's no what? If it's open, there's no top. It's open box. So how many sides? Because we're doing surface area, right? So how many sides was that be? Because a cube has 6 sides, yes? Oh, what? 5. Okay. So if we're doing surface area is of all the surfaces, right? So we have surface area would equal x squared, because that would be the bottom. And the sides, there's 4 sides, and they would be x times h. Correct? Like, that's what it would be. So now, it wants to maximize the volume. So what equation do I need?
Your volume.
The volume. So volume is what?
Base and height.
Base times width times height. But our base is x squared, yes?
Yeah.
So be x squared h. Okay. I need to quit writing over there. So I have 2 equations, but the one I want to maximize is the what?
The volume.
The volume. We want to maximize the volume, so that's the one we're going to be taking the derivative of. So my problem being is I have an x and an h, correct?
Yeah.
And I only want one variable, not 2. So I do know that the surface area is 108, correct? So can I solve this equation for either x or h?
Where did you get the 4 from?
Because there's 4 sides.
So,
X squared is... X squared's the bottom, because it's a square base. And then it doesn't tell me... it doesn't say that it's a square like a cube. So we don't know for sure if the height is the same as the base. So we need to solve this equation for either x or h. Which one do you think it would be easier to solve for, x or h? H, because there's one h, yes? Okay, so we're going to subtract x squared and divide by 4x. So 108 minus x squared over 4x. So now we're going to substitute that in for h. So we have v equals x squared times 108 minus x squared over 4x. Can I simplify that?
What can you take out there?
I can,
Squared?
well,
Or no?
I can take out that x and one of those, yes? Okay. So this is 1/4 x. So I need to distribute 1/4 x in. So V equals, well, 108 divided by 4 would be 4 goes into 10 twice with 2.
Did you
So
get the 1/4 from the 4?
yeah.
Okay.
So 27x minus 1/4 x cubed. So I just distributed. Just making this easier to work with. Now I need to maximize the volume, so I need to find the what of the volume.
The next
The what?
Oh, the derivative.
The derivative. So dv dx, the derivative of the volume with respect to x. That's what dv dx means, correct? Okay, so what do I get?
27 minus, oh no,
Mm-hmm.
3/4? I don't really know how you do that.
3/4
3/4
x
squared.
squared.
No,
Yes?
oh, that. Oh,
Okay, so now I need to find the what of the derivative.
the second one.
Nope.
Oh,
Min and max come from the critical numbers, which come from the
yeah. First derivative.
the zeros of the first derivative, yes?
Yeah.
So I'm assuming we're adding over 3/4 x squared. Multiplying by 4/3. Three is 9, so 4 times 9 is 36 equals x squared. So x equals plus or minus 6.
Wait,
Oh, what?
wait, why is that plus or minus?
Because you took the square root.
Um,
But x is the length of the bottom, yes?
no.
Can I have negative 6 inches as a length?
No.
No. So the answer is plus or minus 6, but the only good answer is 6 inches. So it says, the question is, what are the dimensions that will produce the box at the maximum volume? So we could do the interval. They do, if you look in the book, they'll do negative infinity to 6, and then 6 to positive infinity, and make sure that that's a maximum. But guys, you only got two answers. You got negative 6 and positive 6, and you can't use negative 6, correct? So 6. So my dimensions would be 6 by 6 inches by 6 inches by what? How do I'm going to find my height? Plug it into h. So 108 minus 36 over 24. So 72. 72 over 24. Which is
I don't know where you're at.
72 divided by 24.
3. I gotta write my steps on this, man.
Okay. So my dimensions are 6 by 6 by 3 inches. And I keep erasing that. So how did we figure out what we were doing? Why did we do 108 equals?
Because the surface area is 108.
Right, because it tells me the surface area is 108, so that gives me an equation that I can use and solve for variables, right?
Yes.
Okay, and then why did I do volume?
Because we need the maximum.
We need the maximum volume. So whatever you're minimizing or maximizing, that's what you're going to be taking the derivative of.
Okay.
Make sense?
Yeah. Wait. Would it still be the same thing for the minimum volume?
Yeah, because you get negative. There's not like a minimum volume. Does that make sense?
Oh.
Like, because your graph is gonna, you can't use the -6. So it's gonna be the only extrema that you can find. Does that make sense?
Yeah.
Okay. So on page 220, if you want to write this down, you may. I am not going to sit here so you can write it all down. But this is basically what it's on page 220. You can find it. It's there. Okay, guidelines for solving applied minimum and maximum problems. Identify all the given quantities and all the quantities to be determined. We knew we had surface area and we knew we had volume, correct? If possible, make a picture. Always make a picture. I don't think we've done one application problem this year that I haven't drawn some sort of a picture because it helps me label and think. Write the primary equation for the quantity that is to be minimized or maximized. I probably do that I probably do that later. I usually write the equation. I usually do 3 first. The secondary equation, because that's what I have numbers for. Does that make sense? But does it matter really which one, 2 or 3, comes first? No. So the primary equation is what you're going to be maximizing, that you'll be taking the derivative of. The secondary equation is it's going to help you do that to get it down to one variable. Determine the feasibility of the domain. Positive and -6. Could we use both of those? No. Could we use both of the answers sometimes? Yes. Then we would have to, Jaden, plug it in and see which one gave me what I was looking for.
Yeah.
Okay. So if I had 2 answers, like if I had 3 and 5, well, I'd have to plug in 3 and I'd have to plug in 5 and see which one gave me the maximum volume.
So if you have 2 numbers, you're going to have to see which one.
You're going to have to test which one is correct.
Unlike this one, we knew it couldn't be.
Right. Right, because if you have a negative measurement and it's not feasible to have a negative measurement, you have to figure that out.
Yeah.
Okay, so now if I gave you something where it talked about like water, where negative would be below sea level, a negative would work, correct? So you would have to plug in both of the numbers to see which one,
So
depending.
Does it depend on the problem?
Yes.
And like just what it's asking?
Right. Okay. And last, determine the desired maximum or minimum values using calculus techniques. So plugging them in. Okay. So we have a rectangular page. Is to contain 24 square inches of print. The margins at the top and the bottom of the page are 1.5 inches. The margins on the left and the right are 1 inch. What should the dimensions of the page be so that the least amount of paper is used? So if I were drawing this picture, my picture would look like this. And I'd have 1, 1, 1.5, 1.5. And they used X and Y, but I would assign some variable. Okay? Basic picture. And that is completely sloppy with this stupid pencil. So, it says it contains to contain 24 square inches of print. So what is my print dimensions?
24.
Right, but what are they? X and Y, yes? Because X and Y is just as the print. So we know 24 equals x times y, xy. I was going to say plus. It's area. Area is not plus, is it? Okay. But the dimensions of the page, so this is print, but the area of the page is what? What would the length be?
1.
The length would be this whole thing.
2. Wait, what?
This what would an equation for that? What expression for that be? You have 1, you have y, and you have 1, and you need the whole length. What do you need to do with 1, y, and 1?
Y equals 1.
Don't you need to add them?
Yeah.
So that would be y plus 2. Make sense?
Yeah.
The length of that?
And the other side would be 1 half times x. Wait, no. Then we have to add those together. That'd be 3.
3. Oh, x plus 3. Now, does it matter if I put 2 plus y and 3 plus x? Does it matter?
No.
No, it's addition, right?
I don't know. I think I need the whole thing. I don't really know.
Smaller, medium, short.
Medium.
Okay, so the page dimension is the one we need to get the least amount of paper, right? That's the one. And least amount means we're going to what? Minimize or maximize? Min. Yes, ma'am.
Wait. So last time we had volume, and this time we're doing area. So am I always gonna have a second thingy?
2 equations?
Yeah.
Yes.
Okay.
It just depends on what the problem's asking.
Right, you will always have 2 equations. It just depends on what. Like the last one, we had surface area and volume. And this one, we have 2 areas because we have the area of the page and the area of the print.
All right. This is getting confusing, but we got it, Miss May.
Yep, and it really, I'm going to tell you guys, I read these problems once, and then I go back and start writing down what I know, and I probably go back again and read the question. Like, what is my question? What am I trying to answer? You cannot read an application one time and know how to do it.
Oh, I need about 5 times.
Yes. Okay, so we are obviously going to be differentiating the area of the page, correct? Because it says what are the dimensions of the page for the least amount of paper. So we've got 24 equals xy. What do you want to solve for, x or y?
X.
X? So you're going to solve this for y. Do you want to get rid of x or y in the page equation?
Why?
The y. Okay. So you need to solve this one for y. You got to solve this. You have to solve this one for what you want to replace. Does that make sense?
Yeah.
Okay. And I knew you guys wanted x just because we're used to x, right? So y equals 24 over x. That was an easy one. So I can FOIL, because I'm going to have to FOIL that out, yes? Yeah. Unless I want to use the product rule and to find the derivative, and I don't want to use product rule. Do you want to FOIL before we substitute or after we substitute? Okay. So then this would be what? X, y plus 3y plus 2x plus 6. So x times what now?
Y.
And what is
24 over X.
24 over x?
Oh, yeah.
Plus 3 times
24
over x.
plus 2 times 24 over X.
No, plus 2x.
Oh, I thought
X is x.
Yeah.
Okay.
And then plus 6.
Well, the first one, the x's are going to reduce, right?
Yep.
So 24 plus 6 is 30. And then plus 272. X to the negative 1, because we're going to find the derivative, so I'm going to bring the x up. All good?
Wait, what just happened? How'd you get 30? We talked about that.
24 plus
24 plus 6.
Oh.
Okay, and then plus 2x. So are we all ready to find dA dx?
So, did you, on the 72, that negative 1 is coming from, like, the x moving up?
Yes,
Okay.
so I can find the derivative without having to do the quotient rule.
Okay.
Because it's just x, there's no need to use the quotient rule, right?
Yeah.
So derivative of 30 is 0. And then I've got negative 72 over x squared plus 2. So I have my derivative now. So I set it equal to
0.
0. So I'm going to add 72 over x squared over. And then what?
And then
Multiply by x.
Multiply by x squared. And then divide by
2.
2. So you get 36 equals x squared. Take the square root. So x equals plus or minus 6. But it's a measurement on a page.
Or we're finding, like, the critical numbers right now?
Mm-hmm. So I have x equals 6. But the question is, what are the dimensions of the page that will use the least amount of paper? So x is 6, so y is
4.
4, and I need to plug them into the dimensions of the page, right? So 4 plus 2 by 6 plus 3. And we get 6 by 9 inches.
See, I would have never put that thing back into there, Miss Smith.
Okay, so that again is what when we need to know what we need to ultimately find. Okay, because it wants the dimensions of the pages. Well, the dimension of the page was right here, and I put page. When I did this myself, I put print and I put page, so I remembered which one was which. And you all know how important it is to be orderly with your work so you know where things are and can find it. Whether we do it or not is another thing, but we know the importance of it, right? So the next one that we have is a rather long problem. So we'll set it up to the derivative, and then we won't finish it today. You can finish it at home, and then we can talk about it tomorrow. You can find the derivative. The derivative takes a while. So like on my paper, here's where I find the derivative. I'm sorry. This is where I solve for 0. So if you guys, we might get the derivative, but I want you guys to try to solve for 0, and then we can go over it tomorrow and make sure you did it right. Okay? Because
I didn't get basic ones.
well, I want you to try. Okay? So this is the last one. Okay, so 2 posts. One post is 12 foot high. The other post is 24 feet high. They stand 30 feet apart. They are to be stayed by 2 wires attached at a single stake running from the ground level to the top of each post. Where should the stake be placed to use the least amount of wire? Okay, so you start your pictures with a post and a post. Well, I started mine with ground, post, and post. And give yourself a point not in the middle. Why don't I put it in the middle?
Because then you'll think it is in the middle.
Because you'll think it is in the middle. And this one's 12, and this was 28. The whole thing is 30. So if I make the little one x, that means the big one is 30 minus x. And then if I name this y and this z, and I've got right triangles, correct? Okay, so what we're going to be doing is the least amount of wire. What is the wire? What variables are the wire? Y and Z. So the least amount of wire is going to be W equals Y plus Z. Correct? So that's what we're ultimately going to go for. So I'm going to erase my picture so I have room to write now. So I have how many right triangles here?
2.
I have 2. One is associated with Y, correct? And the other one is associated with Z. What is the variable but that both of those triangles have in common?
W.
A what?
W. X.
An X? Both just the triangles. Okay, they both have an X in common. So that means I need to set up equations, solve them for Y and Z, and then use our X's, right? Okay, so little triangle. Right triangle, need to solve for sides of a triangle. What do I use?
A squared plus B squared equals C squared.
Okay, so Y squared equals
12 squared.
so 144 plus X squared. So Y would just be the square root of that, correct?
Yeah.
Trying to conserve some room. Okay, so that's the little triangle. So the big triangle is going to be Z equals the square root of 28 squared
Squared.
plus
30 minus X.
squared. So this is where I got to make sure I square the quantity correct, don't I?
Yeah. So the Y is the small triangle?
Yes.
Okay.
And this 30 minus X, guys, you could switch these two around. It doesn't matter, does it?
No.
No. Okay, so this one's ready to plug in, the 144 plus X squared. Z is not quite ready to, I probably need to do some expanding and condensing with that one, right? So 28 squared is not one that you are supposed to know, but we can figure it out, and it's 784. plus, and remember when I square a quantity, you square the first thing. So 30 squared is 900.
Oh, yeah, 90.
Sign of the middle, and then it'd be 30 times x times 2, which would be
30 times x times 2? 60x.
60x, and then plus x squared. So z is going to equal the square root of x squared minus 60x plus 1684. Right? Okay. So now that I have y and z both in terms of x, can I plug it into my wire equation to find the derivative? Yes. So wire equals the square. Actually, I'm going to just make that to the 1/2. Can I just make it to the 1/2?
Yeah.
Because I'm going to have to find the derivative. So to the 1/2 plus x squared minus 60x plus 1684 to the 1/2. So now I find dw dx. So I have to use the chain rule.
1/2.
1/2.
1,
4 plus x squared to the
3, 2, no.
negative 1/2 times
2x.
Plus
We go to the other one now? Okay. 1/2. 2x minus 60x.
no x squared. There's no 2x. X squared minus 60x. Okay,
Yeah.
I was
I
hoping.
wrote it down.
Okay, good. I'm wearing off on you.
Yeah.
To the negative 1/2
Yeah.
times
2x and 60.
minus
Or-
60.
Yeah, minus 60.
Okay,
And you do leave those together? I kind of got that. That was pretty easy.
so now, well, half of 2x, yes, is just x.
Yeah.
And the negative goes in the denominator. So that gives me x over the square root of 144 plus x squared plus all this comes down at the bottom, the square root of x squared minus 60x plus 1684. And then half, can 2 go into 2x minus 60?
Yeah.
Yeah, so it would be x minus
30.
30. So now you're going to have to set that equal to 0. I will give you a hint. Subtract over 1 and then cross multiply. But it's going to be a lot, guys. And when you have to, you're going to have to square, what was the big number I had to do?
Why did you put them back in like the square root?
Because when we solve them, when we work with them, it's easier to see a square root, I think. Because you know eventually you're going to have to square it to get rid of the square root, right?
Oh, yeah.
So I want you to work, like as part of your assignment, I want you to work on like trying to solve that.
I guess, Miss May.
And you can do some work. You can do some work and then come back to it later. You don't have to start with it, okay?
I ain't starting with that. No,
Okay.
it's not.